Okay. Hi, good morning, everyone. Welcome to Fit 5136 again. And today is week 11, and then we have Michael Fu, who is my PhD student, who is an expert in the this area, AI for software engineering. And it is our great pleasure to have him to speak about what is AI and how can it be applicable to the software engineering today. Okay, so yeah, over to you. Yep, yep.
Yep. Thanks, Cla. So I'll start by sharing my screen. Okay. So just confirming, can everyone see my screen?
Yep.
Yeah, okay. Sure. So I'll start. Hello everyone, I'm Michael and I'm class PhD student. So for this week, basically we'll cover advanced topic of software engineering, which is around AI for DevOps. So as you experience from week 1 to week 10, we have mimicked the DevOps workflow throughout your assessment 1 to assessment 3. And this week is because everyone knows that AI is developing and they can actually be applicable to many software engineering scenarios. So in this week's advanced topic, we wish to cover you a really broad overview of how AI can be applied to the software engineering workflow. Yep. So if you have any question throughout the talk, feel free to raise your hand or prompt the chat. So I'll answer your question anytime. So basically in this talk, I'll cover both from research and industry perspective. So we'll have example from research community as well as some AI application from the industry as well. So this is my brief introduction. I'm a final year PhD student, and my research is around software engineering, security, and deep learning. This basically I develop AI-based security practice for software engineering, and that's why I'm here today to introduce you some AI application for software engineering. So this is the overview of today's talk. I'll start from covering the background of artificial intelligence and give you some motivation of why we have this talk today. And I'll start introducing what is AI and what is the DevOps paradigms. So basically a brief introduction about AI and software engineering. After that, we can talk about the AI for DevOps, basically development and operation, and how we can integrate AI into DevOps for both enhancing automation and enhancing the security of software development. And then I'll conclude today's talk. So the background is actually around humans and machines. So we know that artificial intelligence, they are basically mathematic algorithm implemented in the computer. And basically the discussion of comparing human with machines, it has been a long discussion since like 40 to 50 years ago. So I wish to share with you this talk. This is just 1 minute video just to highlight a comparison, the difference between human and machine and as the background of this talk. So I'll play this video real quick.
Well, these guys are fast. If one compares what computers can do to the human beings, we find the following rather interesting comparisons. First of all, if I give a human being a problem like this, I'm going to ask you for these numbers back, every other one in reverse order, please. Right? Now, I'm going to series of numbers, and I want you to give them to me back in reverse order, every other one. I'll tell you, I'll make it easy for you. Just give me the numbers back the way I gave them to you. You ready? 1, 7, 3, 9, 2, 6, 5, 8, 3, 1, 7, 2, 6, 3. Anybody going to be able to do that? No. And that's not more than 20 or 30 numbers. But you can give a computer 50,000 numbers like that and ask for them in any reverse order, the sum of them, or do different things with them and so on, and it doesn't forget them for a long time, etc. So there are some things that a computer does much better than a human, and you'd better remember that if you kind of compare.
Yep. So yeah, basically in this video, it highlights that the computer can actually memorize a sequence of number real quick for even thousand or hundred of thousand of number, but that is not the advantage of human. And this, like the comparison between humans and machine has been a long discussion, like since 50 years ago. And this talk is actually covered by Professor Feynman. And the talk is about can machine think. So if you are interested, you can click to view this YouTube video. Basically, he discussed the advantage of human and machines. And basically, during that time, even the machine can memorize a sequence of number. They couldn't actually recognize the image and picture. For example, they couldn't recognize the human face because of different angle or different light condition. It will affect the prediction accuracy of the machine. However, now in 2024, we can actually train deep learning model from computer vision domain. Basically, we feed the model 100,000 of image, and they can actually recognize human face in no matter what condition we have. Even we flip the image, the computer can also recognize that this face is for it's this person. So basically, it thanks to the growing computer resource like GPUs and cloud computing, and then we have terabytes of data to train the model to recognize the human face. Basically, it solves some problems that is raised like 30 years ago. So the motivation of this talk is so a short conclusion is that AI will not replace all of the software engineers, but it definitely will enhance some of the repetitive effort from the human. So the future software engineers, they may need to know how to work with AI instead. So you will need to learn more than the software engineers before, because like imagine 10 or 20 years ago, we don't have these AI tools. However, now we have them, and they can actually reduce some of the manual effort from the human. We don't need to write a repetitive code by ourselves, but we do need to know how to work with these AI tools. So that it is important to understand what is AI, and it's actually the motivation of today's talk, give you a broad overview of AI application to software engineering, so that you can know how to work with these AI tools in your future career. So the goal is to introduce an overview of current AI application within the DevOps workflow. Before we can do that, let me first introduce what is artificial intelligence. So in this talk, I will focus on traditional machine learning and the deep learning algorithm. So let's first look at what can AI do. Basically, in the software engineering context, they can detect software bugs. So basically, how we achieve that is we can collect the software metrics as feature and use machine learning model to predict whether this software project has bug or not. Basically, the feature that we can consider is number of developer, number of line in your software code, etc. And for the deep learning model, it's more advanced, where we can just transform the source code data into mathematical metrics, and then we do the computing metric multiplication in deep learning model, and then we can predict where exactly is the bug by learning from the past data of software bugs or vulnerabilities. And they can also estimate story point in agile software development life cycle. So during the agile planning, we may have some issue or story description. We can transform this description into metrics, and we use deep learning model to predict the story point. So we don't need the human judgment to determining the story point for our issue report. And we also have, outside the context of software engineering, we have autopilot software system developed by Tesla and NVIDIA. So basically, this is a computer vision model, and we have the camera around your car, and each camera will capture the real-time image to the cloud computing system, and it can perform real-time prediction using deep learning model to achieve the autonomous driving. We also have some more and more software companies. They are using AI, for example, Netflix. They are using deep learning, machine learning to recommend the movie that you like. And also for Airbnb, they recommend you a place to stay for your vacation. And for Uber, they use machine learning to figure out the optimal path for your trip. So let me first introduce a little bit about traditional machine learning. So basically, we have linear regression model. Basically, the input is the numeric data. And based on these numeric data, we can fit a regression function like this red line over here. And we can do price estimation, sport analysis, and many more use case for linear regression. So basically, it is a simple mathematic formula. And we also have a decision tree model. Basically, we consider all of the different features. In this case, we want to ask whether a person is fit or unfit. And we have different features. The first feature is about the age. So if the age is less than 30, we say yes. And we go to the next question, whether this person eat pizza or not. If it's less than 30 and eat pizza, then we say, yes, this person is unfit. This is just a really simple example. In reality, we actually we can have like more than 10 or 100 decision over here. We will have a bigger decision tree to do the prediction based on our feature. And we also have some clustering algorithm. Basically, using this clustering algorithm, such as k-nearest neighbor or k-mean algorithm, we can figure out the cluster within your data. So this is commonly used in recommendation system, pattern mining, or used to do the data mining, basically to figure out whether there is any clustering characteristic in your input data. And more advanced machine learning algorithms are available, such as random forest, which is an advanced version of the decision tree algorithm. And we have support vector machine and XGBoost. So if you are interested in learning machine learning, I would recommend you to check out this scikit-learn library. So basically, this is a Python library that you can learn. You can start learning some basic material about machine learning. And at Monash, we also have an introductory level of machine learning course, which is FIT 5201. And yeah, let's talk about deep learning. So basically, deep learning is that we input data to matrices. We can input any kind of data, for example, textual data, your source code, or your story description. And we also can have audio, video, and image data. But before we can use this data to make prediction, we need to first transform them into mathematical matrices, because essentially the deep learning model are actually they are actually just mathematical matrices. So to interact with this matrices model, we need to first transform our data into matrices. And there are different ways to transform data into mathematics for different kinds of data. But I wouldn't talk about that technical detail today. It's just so you know that we need to first transform our data to numbers. Then we can work with deep learning model, and the model will make the prediction based on our input feature and the insight learned from the past data. So there are multiple architectures such as multi-layer perceptron, recurrent neural net, convolutional neural net for image data, graph neural networks for learning the graph structure of your data, and more different architecture. And the turning point of deep learning is actually the transformer architecture proposed back in 2017. So if you are interested in learning this architecture, you can click this link to access the original paper. And basically, these architecture are the backbone for every large language model and generative AI that you see today. For example, ChatGPT, the Claude that you are using, the Gemini by the Google. So they are all using the transformer architecture. So there are actually 3 transformer architecture: encoder only, decoder only, and encoder decoder model. And the advantage of transformer over the previous model architecture is that they can be trained with large amount of data, and they can have we can scale the model parameters inside the model. So for example, in ChatGPT, they have more than 1 trillion parameter, and they are trained upon terabytes of data. So they can be used for many different use cases including under the software engineering context. So yeah, so the magic is that we feed multiple data. We have some pre-processing filtering process to filter those data. After that, we transform those data into mathematical matrices, and then using some metric operation, and then we can train an AI model. So basically, the training is the so-called gradient descent. We won't go into too much technical detail, but the mathematical theory for training a deep learning model is from the chain rule of the calculus. So that's just the basic theory of deep learning. And we can see that the model size for language model has been increasing from 0.05 billion from 2017, the vanilla transformer, increased to 1.6 trillion. And this is just until the 2021. So now it's 2024. So the model size is like even more crazier than this graph you see here. So people are building larger and larger model that has more and more powerful capability to do various kind of tasks. So this is a brief history of LLM and Gen AI. Basically, we have different types of model. So this highlight in orange box is models trained for general tasks. So they are trained using some natural language data such as news and online article. We also have the model that's specialized for software engineering, and they can tackle source code related tasks. So basically how we train this model is, for example, we parse some open source software application. We parse those source code, and we feed this source code to the deep learning model to let them learn how to do the coding for different programming languages. And here are some good learning resource for deep learning. Basically, if you're interested more and more people are using PyTorch nowadays rather than TensorFlow. So it's definitely a good starting point for you to learn the deep learning, how to implement a deep learning model, how to train a model and evaluate your model. And on the Hugging Face library, there are many open source model that you can play with. And we also have some free lectures you can search on YouTube. This is just one example about computer vision. I took this one like a few years ago. It was a really good lecture. And Stanford actually open sourced their deep learning lecture on YouTube. So you can search Stanford University deep learning. You will find more. You will find out more. And at Monash, we do have deep learning course as well. I also took this one when I study my Master of IT degree. And yeah, it gives you some to learn some mathematics behind deep learning. Yep. So do we have any question about machine learning and deep learning? If you have any question, please feel free to prompt the chat. Yep. So if not at the moment, I'll start talking about the DevOps paradigm. And after that, we can talk about how AI can be applied to this DevOps workflow. All right. So yep, so we can see here the DevOps paradigm, including planning, building, testing, deployment, and operating, and also monitoring. And then we'll back to the planning. So it's a iterative procedure of software engineering. basically, this is also how we want to design this 5136 unit. From week 1 to week 3, for your assessment 1, we were mainly focused on the planning step, and then we start in assessment 3, you start doing some implementation. So basically, it's building your software, and we also try to do the commit inside the GitLab version control system. So it's just to mimic this development and operation. But we do have but for the operation, since we are not actually deploying our app and do any monitoring, we can only mimic until the implementation and the deployment. But for the operation and monitoring, I think you might experience this workflow when you start working in a company or in your future career. So let's first talk about the operation. So the operation team, they actually need to deal with the planned events such as deploying, upgrading, or decommissioning unused component in your software system. And they also performing maintenance on hardware and software system. They also need to deal with the unforeseen events. For example, responding to error caused by any bugs or responding to natural disasters to the hardware system. So a typical example is, remember 1 or 2 months ago, there was a CrowdStrike blue window error. It's actually because of one of the security file in the Windows system that is, they had some mistake in that file, and it actually affect millions of different computer software. So during that time, the operations staff, they need to tackle this unforeseen blue screen event to solve the problems as soon as possible for the customer, to solve the blue screen issue caused by the CrowdStrike security file. So that's a really typical example of the unforeseen events over there. And they also, so we can imagine that in the operation team, we need to employ IT professional with a wide range of skills, like programmer, DBA, tech support, network engineer, and also hardware engineer. So the operation team, the people in the team, they actually don't know the architecture, and they consider every software component in the system, plus how those software components are glued together. It's so because the operation team, they didn't develop and they didn't implement the software, so that it is really it's really time consuming to read and understand someone else's code. So by saying someone else's code, I mean in the operation team, they didn't write the code by themselves. Instead, those code are implemented by the development team. So before they can maintain the code or update the code, they need to first comprehend and understand the code written by the development team. And also the enterprise system tend to evolve toward it tends to support more and more functionalities. So the software becomes more and more complex and more, and it would be even more difficult to understand by the operation practitioners. So this is especially true if the original developers have moved to the new projects. So this is how, so basically a software and the nature of software engineer job is like you would probably work in the same company for a short period of time, for example, 2 or 3 years. Once you complete 1 or 2 projects, you tend to move to other company. The reason for this nature is that it's your way to increase your salary faster, because when you move to the new company, they tend to hire you with a higher salary. So software engineers tend to move from company to company, after they complete one or two software projects. But now it would be really headache for the operation team and software maintenance team, because they don't have the original developer that developed this software. So they need to first understand what are these guys doing during the implementation before they can make any update to the code. I think you will probably have the same feeling when you are doing assessment 3, because you need to read your team members' code, and sometimes different people, they will have a different logic, different coding style, and different documentation style. So sometimes it's really difficult to read others' code. And yeah, sometimes if you don't document your code really well, it is also difficult to read the code implement by yourself as well. Like you implement the code today, and 6 months after, you just couldn't understand what you were doing 6 months ago. And yeah. So in the past, deployment was a traumatic process, because the development team and operation team, they're actually at two different silos. They didn't actually work together. They are two separate teams. So whenever the operation team need to do anything to the system, they need to first understand the development, what were the development team it was doing before they can make any update to the software system. So the central idea of DevOps is, why don't we combine and make development and operation team closer so they can communicating with each other more, instead of trying to let the operation team comprehend what development team was doing afterwards. Instead, we wish to let those two teams work together throughout the software development process, throughout our iterative development process. So the operation team would spend less time to comprehend the code written by the development team. So the DevOps, some of the DevOps principle is that we wish to bring the development and operation team closer, and we follow an agile mindset instead of waterfall mindset. So we just do we develop the software incrementally instead of deliver the software just one time, like using the waterfall software engineering. And we wish to turn the deployment into a non-event. So because we develop the software incrementally, we can deploy part by part instead of deploy a large software all at once. This actually makes the operation and development much more easier. So by combining the development and operation team closer, it actually won't complete it, solve the challenge, but at least we can mitigate the headache for the operation team somehow. Yep. So this is the DevOps workflow. So we first have the planning step. Basically, we gather the requirement from the client, and we plan the features. We do the task assignment, and we do agile planning using, for example, Trello board. And after planning, we can start the development, which is your assessment 3. And for planning, it's like your assessment 1, where we write the user story and we draw some diagram before we implement the software. Yep. So the development, we basically do coding implementation, and the code commit, it's also included in your assessment 3. Basically, we do code review and we provide feedback to our team members' code. So we can do the code review within the version control system, such as GitHub or GitLab. And before we merge into the main branch, we want to do the code review so that we don't interrupt the main branch, and we don't crash our software in demand. And after the commit and code review, we can build the software, test the software, and start deploying our software. Basically, we transform the code to executables, and we perform some stress tests of our application. And after the deployment, it starts operation, and the apps is available for a customer to use, and then we monitoring the app performance in the production scenario. And after that, we will have continuous feedback of how customer interact with our software, and if there is anything wrong with our software during the running. So we get continuous feedback, and then we back to the planning, and we refine our software, re-implement some new function or some refinement, and then we do the commit testing and once again deploy the software. So yeah, so basically this is how development and operation works. And I think you have experienced some steps throughout your assessment 1 to assessment 3, and your assessment 4 is about software testing, which is also included in the DevOps workflow. Before we can deploy our app, we wish to write some test cases to test your software, right? And yeah, next I'm going to talk about the AI application for DevOps. This is main focus of today's talk, and I'll focus on the automation and security perspective. So first, why integrate AI into DevOps? So the first reason is the automation, because some workflows, it requires large amount of manual efforts. For example, in the code review, you may need to review like multiple, maybe 100 or 1,000 lines of code. With the help of AI, maybe it will reduce this 100 or 1,000 line to just a few lines of code, or 10 or 10 lines of code that you need to review. That is the most important part. So AI can prioritize some important code for you to review, instead of letting you to review all of the code inside your software. And there's another reason is security. So the bugs and vulnerabilities, they are prevalent in source code, and AI can actually learn the buggy or vulnerable patterns from historic data and help detect the defective code in a large code base. And security really matters, because we can see that security threats are actually on the rise in Australia and as well as around the world. So in Australia, there is a 13% to 25% increase for a number of cybercrime reports and the number of publicly reported software vulnerability each year. So it's really a serious problem for software engineering. And we can see that the technology companies, they are actually spending a lot of money in Australia as well as in different countries to enhance the defense for cybersecurity. And the government of Australia, they also have a planning of 2023 to 2030 Australian cybersecurity strategy to combat the cybersecurity issue. So if we can somehow integrate AI-based security methods in your DevOps workflow, we can consider the security perspective, the security issues during the software development. It can actually reduce a lot of efforts to detect any potential defective after the deployment, because after deployment, to detect the software bugs, it will be even more complex than detecting bugs during the development step. So the first step we'll look into the AI application for the planning. First of all, we have the Trello board, and we also have AI integrated into the Trello board by Atlassian, but it is so basically they just integrate AI into Trello early this year. It can generate and summarize and also improve the spelling or your grammar for the user content. So when you type anything into Trello card, the AI model will actually complete some context for you, or generate or summarize your story description in your Trello card. And it can also help you brainstorm some new content based on the topic provided by the user. And it can find and insert some action item automatically onto user's card based on the content. So if you start a free trial with Atlassian, you might have experienced some functionality powered by AI over here. And I'll play a short demonstration video for you just to let you know how AI is working in the Trello board.
Trello AI is available to premium and enterprise users to change the way you work and collaborate in Trello. With the introduction of AI to Trello, you can boost your individual productivity and accomplish even more as a team. Summarize longer card descriptions for a high-level look at the most important information. Or identify action items within a message to quickly and easily craft a to-do list. You can also use Trello AI to adjust your own messages by fixing errors or changing the tone. The brainstorming feature can even help you kick off your next project or craft your next big idea. AI can be used to transform teamwork across all of your favorite Atlassian tools. In addition to Trello AI, Butler Automation is still available for all users to level up their productivity. Simply click on the Automation button to access this feature. Join the future of work and upgrade to Premium or Enterprise today. Learn more.
Yep, so actually highlight some of the AI functionality that Atlassian integrated into their Trello board. So now we can see that once you have idea, you can feed these idea into AI, and it will generate some content for you instead of letting you to filling all of these content by yourself. So it actually enhances productivity. But remember, you do need to have an idea to interact with the AI. So the role of human is still important because you need to plan your software, what function you are going to implement. After you have some high-level overview of your software features, what you are going to implement, you can chat with AI and make your planning more fluent and faster. But you do need to have your idea first before interacting with the AI model in the Trello board.
Trello AI is available to
Okay, so the next one is the Jira. So it is also the Atlassian product. It basically, Jira is an issue tracking system. So if there is anything wrong or any new features that we want to implement in our software system, we will submit an issue inside this Jira issue tracking system. And basically a developer, what their daily task is, some of the developer, they need to check the issue in the Jira in this issue tracking system to just so they know like what they're going to do today, what kind of issue they're going to solve today. So the AI and Jira issue tracking system, basically they wish to automate some of the workflow for this kind of developer. They automate the issue search, explain the technical terms in the issue to enhance the communication quality between different development team or between the client and developers. And also they answer the question promptly by integrating the AI into their Jira issue tracking system. So I'll play a short demonstration video of how this AI work in the issue tracking system. Yep. So basically, the AI in Jira, the problems they are solving is they found that when developers are searching relevant issue, it is really time consuming. So they actually integrate AI to automate this kind of search to make the job for a developer easier. And yeah, it also integrates some of the language model to solve the language barrier, explain the technical terms, or explain different language for developers from different countries. So actually automate some part of the issue tracking workflow and make it easier for developers. So next we have AI in planning step. This is a research. And so this is a explainable story point estimation. So basically in this research, we fine-tune a language model called GPT-2. So it's a previous version a few years ago before ChatGPT, right? And basically we use this model to estimate the story point based on the issue title and description. And we explain the prediction based on the historical training data. So I'll show you what it means. And so this is an example overview. And let me do some demonstration of this app. So this is a web application of this story point estimator. And in this estimator, we can enter a task title that we wish the model to estimate the story point for us. In this case, we have the issue title like this, Windows 10 SDK is not detected. So based on this kind of issue, we use the model to estimate the story point. So it gave us the story point of 5. And it also, like if we only present this kind of prediction, the developer will probably not trust the prediction from the model because it's a little bit suspicious how you derive the story point of 5 based on this title. So to solve this trustworthy issue, we propose to actually present those similar issue in our training data that has the similar story point. So in this case, the keyword is Windows. And we do have some Windows related issue in our training data that has similar story point as somehow the evidence of this prediction to enhance to bridge the AI tool with developers to enhance, to make the AI-based prediction more trustworthy this way. Yep, so this is a short demonstration of the story point estimation tool. And next, we're going to talk about the development. So there is multiple AI application in the development step. So this one is just released 1 or 2 months ago by GitLab. So this is the tool is actually called GitLab Duo. So it's an end-to-end AI partner for faster software development. And it can do issue planning, automation, the code generation or completion during developers coding. And it also has some chat assistant feature. And after you implement your code, when you want to commit to the system, there is a continuous integration and continuous deployment process. And this GitLab Duo also supports root cause analysis for CI/CD. So if there is any deployment failure, it will detect what's the root cause for this kind of failure for your deployment. So here is a short demonstration video. So we'll look at it.
You're a developer working on a mission-critical customer-facing app. Here's how GitLab Duo acts as your AI assistant through the whole software development lifecycle. Instead of wading through weeks of comments, GitLab Duo summarizes technical needs and infrastructure requirements, instantly generating a to-do list. And all it takes is one click for you to transform your notes into detailed issue descriptions. Now, It's time to start coding. Let's say the task in your first issue is developing a new feature, which requires adding a new method to the existing Java app. You open the Web IDE and describe the task, and GitLab Duo instantly generates the method. You can focus on the core business logic, while Duo handles syntax and boilerplate code. As you work, Duo crafts contextual suggestions to fill in the gaps, speeding up the process. When a vulnerability is detected, GitLab Duo instantly provides a summary and suggests how to fix it. It even generates a merge request that resolves the vulnerability with a detailed description and the actual code. You don't need to be a Go expert to integrate a feature developed by another team written in Go, because with GitLab Duo, the context you need is at your fingertips. It provides clear code explanations for seamless integration. And if you have questions, Duo Chat is there for in-depth help. It's available platform-wide, so you can use its knowledge base to dig deeper. Merge request time. Oh, you've hit a challenge. Your pipeline build fails. What once required looking through hundreds of log lines is now solved with a click. Using GitLab Duo's root cause analysis. Problem identified. Fix suggested. Problem solved. Now you're ready for code review. Select from a list of recommended reviewers based on their expertise and availability. Your tasks are complete, efficiently and successfully, thanks to GitLab Duo. It doesn't stop at coding. With automated test generation, you can catch bugs early. And with the AI Impact Dashboard, you can measure AI's impact in real time. GitLab Duo demonstrates what can be achieved when AI is incorporated throughout the software development lifecycle. Make this a reality and leverage the most comprehensive AI-driven DevSecOps platform for faster, more secure software development.
Yep. So from this video, we know that this kind of tool is actually really powerful because it not only enhance the automation, it also covers the security part to achieve the so-called DevSecOps. So DevSecOps is a new paradigm extended from the DevOps. So DevSecOps means development, security, and operation. So basically, we want to consider the security part. In this video, we saw that the AI, they can suggest automatic fix for your issue and also detect any the build failure for root cause analysis for your CI/CD pipeline. So it wish to automate the security and some of the manual effort from developers during your development. And next one is the GitHub Copilot. So basically, it's integrated in many IDEs such as Visual Studio Code. And in the Copilot research, they found that the code completion supported by the Copilot actually makes the coding 55% faster. And the text to code, and it also Copilot also support text to code generation. For example, we can prompt the Copilot model to create a new button component for our software. And when we input this kind of prompt, it will generate the boilerplate code for us instead of letting the developer writing this kind of repetitive code for themselves. And we also have ChatGPT that support text to code or the code completion as well. And we'll do some demonstration for the ChatGPT. So this is let's demonstrate the ChatGPT for the code automation. This is a dynamic programming coding challenge. So this is a really common problem that will appear in your coding interview for a software engineer job. So in this house rubber, basically these descriptions are the prompt that we are going to feed ChatGPT. So we first inform the task to ChatGPT, And then we ask it to complete the following function to solve this house robber problem. So let's look at this problem together. So this problem is actually from LeetCode. So you're a professional robber planning to rob houses along a street, and each house has a certain amount of money. And the only constraint of this task is starting you from only constraint is that because the house, they have security system connected with each other. So it will automatically contact the police if two adjacent houses were broken into on the same night. So you couldn't rob the two houses in a row. So let's look at some example here. So the first house has a money of 100, and the second house, when we robbed the first house, we couldn't rob the second house. Otherwise, the security will be triggered, right? And for the second case, it's the same. So it's just, we can skip two houses in a row, but we couldn't rob two houses in a row. So that's the only constraint for this coding challenge. So let's put this prompt into ChatGPT. 1 second. Okay. It basically will generate. So it starts from generating some explanation of how it solves the problem, basically the reasoning process, and it generates a code along with explanation. So let's see whether it can solve the problem. And it also explains the time and space complexity of this code. Okay. Let's just run this. It actually passed the 2 test cases. Let's try submit this. The submission is actually accepted, meaning that it passed all of the test cases written for this scenario. So this is a medium difficulty coding challenge, and ChatGPT can solve it within 30 seconds, which is really, really good. So this is just a short demonstration of how we can prompt ChatGPT with a task, and it can actually complete the code function with this kind of medium level logic and pass the coding interview question. So for the security, we will also use ChatGPT to demonstrate some security example. So this is there is many kind of CWE. So CWE is a categorization used to categorize what kind of security vulnerability do we have, security weakness. It's categorization for our software weaknesses. And in this example, I chose the 7A7, which is a kind of a buffer overflow vulnerability. And why these kind of security weakness, why they are dangerous? Because they can cause memory corruption. They are easy to exploit. If you have this kind of weakness in your source code, they will be easy to exploit by the attackers. And they're actually not easy to detect, and they have wide impact in your software system. So that's why we wish to use AI models to capture as much as possible these bugs before we deploy our software. So here is an example of example code of CW7A7. Basically, this memory copy function, we have some buffer overflow concern for this line of code. So let's see whether ChatGPT can capture this kind of security concern. So we'll start a new session and we just copy. So our prompt actually asks whether is there any security problems with the code below, and we paste the code over here to let ChatGPT understand what we are doing. When we input this code, yep, it says, yep, there is a security issue. And it also point out this is buffer overflow related. And it start explaining the problem and explaining the consequence, proposing some potential fix, rewrite the code by checking the chunk size before we input the chunk size to our memory copy function to try to avoid the buffer overflow. So the reason why we have the potential overflow here is in the original vulnerable function over here, we actually don't have any checking, any check before we input the chunk size to this function. So if we implement the size validation, it can actually prevent the potential overflow concern. And this is what ChatGPT generated as well. So it can actually do comprehend the secure the vulnerable code and suggest some fix for your vulnerable code as well. But this is just a really simple example. For some more complex code that consists of multiple different lines, for the vulnerability that across different files, maybe ChatGPT couldn't give us an accurate explanation and accurate repair for that. Yeah. So this is just a current stage of what AI model can do, but they will definitely improve throughout the time. So we do have other AI research in development step. The first one, this example is for the automation. So this is a code completion model. It's called PyCoder, a syntax-aware code completion tool in Visual Studio Code. So the challenge that this paper found is that the existing code completion language model, they don't consider the syntax information, such as for source code, different lines of code, we do have different syntax information, such as the keywords, operators. The compiler actually treat these keywords and operators in different ways than other source code, right? And we also have variable and data type, but they found that the existing completion model, they don't highlight this kind of information for the model, so that we have suboptimal performance for the code completion model. So the solution is that we're trying to infuse the syntactic information into the language model during training, using some tricks, so that we can train a more accurate language model to do the code completion task. So if you are interested in this tool, you can download it from the marketplace, Visual Studio Marketplace, and you can also check the full paper from this link. And we also have some more AI-based research for development. So recently, Microsoft team, they actually introduced a really interesting framework, which is called AutoGen. It actually enables next generation of large language model applications through a multi-agent conversation. So this multi-agent system, they're trying to solve a problem that for some complex software engineering problems, such as software planning, software development, when we use only one large language model, for example, I only interact with one ChatGPT, it actually has really limited performance, because one ChatGPT can be treated as one agent. When we do a complex or difficult task with this one agent, will have limited performance. So the Microsoft team, they thought, why don't we just use multiple ChatGPT or multiple different large language model? For example, maybe combine the Claude model from Google and OpenAI's ChatGPT to gather diverse insights for our software to do our software planning and software development. So they actually propose a framework where people can use multiple large language model. We can combine 3 or 4 ChatGPT together, and we will also include the human agent to check the output from the model. And we can also include some automated software tool, such as static analysis tool, to check the code generated by the large language model. So they designed this kind of conversible framework to let multiple large language model interact with human as well as the tool. And this research actually opens many AI-based software engineering applications. One typical example is this one, chat development. So they develop a framework inspired by the AutoGen framework to basically they have many large language models. So basically we can see that in a software development lifecycle, we have design phase, which is drawing the diagram, gather the requirement analysis, and before doing the coding and implementation. And after the design, we have coding. And after the implementation, we also need some tester to write some test cases to test our implementation before we can make it a software product, right? And yep, so basically we have the instructor, CEO, CTO, co-reviewer, co-tester, and the programmer through our development lifecycle. So in this case, we see there are 10 different agents. And in this paper, these 10 different agents are actually not acting by humans. They are all large language models. So imagine they use this AutoGen framework, and they actually hire like 10 different large language model to mimic a software development team, which is really interesting. But the evaluation they've done is using a data set for a really simple small gaming software. So they use this 10 language model to develop a simple software game. And then they found that this kind of framework can actually improve from the scenario where we just only use one large language model. So this kind of research direction is really popular these 2 years, especially after the AutoGen framework. So it's really interesting how we can use multiple large language model to mimic a software development team. But I think in the future, if we want to build a production level software, we couldn't just use the large language model. We do need some human intervention during the design, during the coding, during the testing, because large language model, they can make mistake. And we also have some ethical or safety concern from large language model. So the future development workflow would be maybe we'll have AI software development team interacting with the human software development team, which makes the software development faster and more secure in an ideal world. Yeah. And we also have some research for AI in development, especially focused on security. So this is an AI-powered security tool in Visual Studio Code. So basically, given a source code like this written in C++, we have a tool powered by multiple different language model, deep learning models that can do the prediction to predict what's the severity of the vulnerability occurred in this code snippet. And it also locate which line is the vulnerable line. And we also suggest the quick fix. So here are some of the prediction generated by different deep learning models behind the tool. Yep, so we have the localization, vulnerability localization, severity estimation, and also explain what kind of vulnerability do we have, and provide some fix suggestion to the developers. So here, if you are interested in, it's available in Visual Studio Code, and you can download from the Visual Studio Code marketplace. You can also view the full paper using this link. So I'll give you a short demo. So this is a simple web application, basically mimic the vulnerability detection of source code. So we have a dataset viewer. So in this dataset, we have multiple software function written in C and C++. So for example, this one, we have a C++ function. Imagine that you are a code reviewer, that you are reviewing this kind of function. It may probably take you 10 or 15 minutes to comprehend this code and to see if there is any security issue, right? So it's a really labor-intensive job to review the code and figure out the security issue. So in this case, let's just fit in this example, index number 6. And let's first look at the label. So the function label, meaning that whether this function is vulnerable or not. And this is actually a vulnerable function. And we also have a statement label over here. So we can see that line number 1, 2, 3, 4, 5, 6, 7, 8, 9. The line number 10 and 11, as well as the line 14, they are potential vulnerable inside this code. So this is a pre-labeled data set. This data set is actually labeled by a security expert, human security expert. So let's select this index number 6. And when we select, it will actually load the model and do the security scanning using deep learning models behind the scene. And we can see it takes some time, roughly 20 seconds. Yep. And it actually point out that, hey, we have vulnerable line 10, 11, and 14. It's quite accurate because it localized the vulnerable line for us. And it says, yeah, potential CWID is 119, which is a buffer overflow reading. So we might have some buffer overflow concern, and it reprint the vulnerable function for us. So this is how this kind of AI-based security tool works. Basically, it potentially save you 10 to 15 minutes if this is a correct prediction. Yep. So next step is the code commit. We have, in the commit step, we also have another version of Copilot, which is focusing on the security in the code commit stage. So this tool is called Code Scanning Autofix. I think they just released it a few months ago. And it actually can generate fixed code suggestion with natural language explanation to explain the code generated by the AI agent to automate the pull request workflow and the issue fixing workflow. So let's play this demonstration video.
Scanning tools help us identify vulnerabilities in our code. But to remediate issues, we must triage alerts, review the relevant documentation, and propose a fix, taking up precious development time. That was until Code Scanning Autofix. Autofix improves the experience by using AI to provide a code suggestion and explanation directly in the pull request. The developer remains in control, being able to make edits using GitHub Codespaces or their local machine, accept the original suggestion, or dismiss it entirely. With Autofix, code security alerts transition from being found to being fixed.
Yep. So it actually integrates some security model to automate the issue fixing in the code commit stage. Yep. And next, from the research perspective, we also have this kind of JIT bot. So this is an explainable just-in-time defect prediction bot. So this kind of defect prediction is because nowadays in a large software project, we'll have hundreds different commits every day. And we wish to predict like which commit has potential defective code. And this JIT bot, it actually collects some software metrics and use machine learning model to predict whether this commit is potentially defective. So the software metrics that we collect, for example, we will collect the developer expertise, number of developers involved in this code commit in this software project. How many lines do we have in this software project? So based on these manually collected metrics, we can do some prediction about the whether this commit is potentially defective at an acceptable accuracy. So it will predict defective commits and explain why the commit, provide some explanation of why this commit is predicted as defective. So that, because when using machine learning model, if we don't provide explanation, probably the developer will not trust the prediction by the machine learning model. So we need to provide some explanation to prove, to reason how the model reach this kind of prediction. Yep, so it's a combination of machine learning plus explainable AI. And this is a example prediction generated by the JIT-bot. So this is inside the GitHub commit page. So we have the commit link E21C988. And based on the machine learning model, we have some software metrics collected over here. And this graph actually explain why this commit is potentially defective. So the main reason is the low experience. We can see the point 1 is the low experience of developers in the subsystem, and the low experience of recent developers, and the high number of deleted lines. So these 3 metrics actually affect the model prediction that leads to the let the model generate the prediction and saying that, oh, this commit is actually potentially defective because we lack some experience. We lack some experienced developers in this project. So this commit is more dangerous than other commit. So we should check this commit and prioritize this kind of commit rather than other commits. And we also have some code review automation research for the code commit step. So during the code commit, we have the code review. Basically, we want to review other team members' code. It's an effective approach because through our code review, we can solve some bugs, functionality errors before we deploy our code and make it make to the production. So it actually ensures the software quality during the code commit. However, we can see that it is actually a labor-intensive procedure. Like in your assessment 3, you probably don't want to read your teammates' code, right? Because it's written in a different logic, makes it really difficult for you to comprehend others' code. But in the code review procedure, most of the time you are not reading the code written by yourself. You are reading a code by other team member or from other software project team. So it's really labor intensive. So people are start building some AI approach for the code review. So the first one is code review recommendation. So we probably will we will train the model to recognize like which reviewer are good at what kind of programming language, what kind of software projects. And based on this training data, the model can recommend a good reviewer based on their expertise to their suitable software project. And we also have code review comments recommendations to recommend the review comments automatically to ease some labor-intensive job from the developers. So next, we're gonna talk about building, testing, and deployment step. The first one is the Ansible. So it is automated configuration management tool. So this configuration is actually for deployment. So Ansible is an open source it's open source automation engine that automates the provisioning and the configuration management, application deployment, and orchestration. So basically it detects based on this infrastructure as code, IAC. So basically IAC is YAML file. And the reason why we have this IAC file is that remember in the agile workflow, we want to build the software incrementally. So we will have multiple deployments every day instead of just one deployment inside the waterfall software development process, right? In the agile workflow, we have multiple deployment, but imagine that each time in each deployment, we need to configure our system. It is really a repetitive, and it makes no sense that we need to reconfigure once again for every deployment in Agile workflow. So people come up with this IA infrastructure as code. Basically, we wrap this configuration into a YAML file. So the system will comprehend our configuration setting by just reading this YAML file. So we don't need to configure the system every time before deployment. We just need to configure this file. And to figure out the any potential failure or potential invalid configuration, we can use some automation approach, either using deep learning or some other automation predefined rules to figure out whether there is any bad code inside our infrastructure as code YAML file to figure out the invalid configuration, to automate this kind of configuration management process. And we also have some similar tools in Puppet and Chef. So this is actually for code deployment and for the configuration management. So next, we also have some research that is doing the automated code testing. So this is assertion augmented test case generation. So nowadays, people are building deep learning models for automated test case generation, because in your assessment 4, you might figure out that some of the test case, they are actually not that complex. And for some test cases, they can actually be generated by the AI model easier, since some of the test case, they don't require complex logic. And in this research, the problems the researcher found is actually, they found that the current AI-based test case generation methods, they lack of assertion knowledge, and they lack of the naming consistency and test signature verification. So to solve this kind of challenge, they basically use a pre-trained language model and infuse this kind of assertion knowledge to the model, basically because just mimic when the human is writing a test case. We have this assertion knowledge, we have naming consistency and signature verification. But for the model, we need to teach them before they can understand these kind of concepts. So they use pre-trained language model to fuse this kind of knowledge to the model and further enhance the accuracy of test case generation model. So here's the full paper if you're interested. And next, we're going to talk about the AI application in operation and monitoring stage. So for this stage, you're probably, you won't experience operation and monitoring in this unit, because we just couldn't mimic the application monitoring step for you throughout your assessment. I think the assessment 3 is, it's like a big headache for you. So if we have this kind of operation and monitoring, it probably is just too difficult for you at this stage. But we also have many AI approach for operation and monitoring. And a really iconic tool from industry is the Datadog. So it's a cloud monitoring as a service tool. And it basically performs real-time app performance monitoring, threat detection, and anomaly detection. So basically how this tool detects the threat and anomaly detection is by analyzing the application log. So it analyzes the log to figure out whether there is any anomaly log when running your application, either using some automated tool or deep learning models. And it has a dashboard to observe the infrastructure, the system log, and the service dependencies for your app. So it's like all of the monitoring are all integrated in this dashboard provided by Datadog. And yeah, let's look at the demonstration first. Yep. So basically, we can see that when we want to monitor the application performance, there are actually many different aspects that we wish to monitor, whether the performance, the system log. Basically, these approaches, we already have it 5 or 10 years ago. But Datadog, they just integrate all of these monitoring together in an all-at-one into an integrated dashboard, so that the operation team, they can just check the dashboard. They know each perspective of our running application. So it makes the operation team's job easier. And also they try to integrate some of the AI approach, for example, for anomaly detection. Before we may have some mathematic algorithm, but now we can also train deep learning model to recognize the anomaly pattern and the anomaly system log faster for a faster response as well. Okay, so the conclusion for today's talk is we have introduced AI application within software engineering, focusing on the automation and security perspective. So we cover from planning, development and implementation, to the code commit, to building, testing, and deployment of software, and also operation and monitoring. Basically, a short demonstration of how a AI-powered dashboard can be designed to let operation team monitor the software more fluently than before. And we also highlight the role of AI in DevOps. So the role of AI would be they can actually automate some simple code generation tool. Also, the test case generation, it basically trying to help humans to achieve some repetitive job for a software engineer. So like 10 years ago, software engineer, they may need to write more boilerplate code than today's software engineer. But so today with these AI tool, we actually have access to many AI-based tools, but we do need to know that we need to provide the idea to those AI tool in order to make it generate useful predictions instead of just some repetitive source code. So the key takeaway is AI-driven automation in development and operations. They actually can accelerate the software delivery and also enhance the security perspective during the development. So we can figure out more and more security issues during development instead of doing the debugging after deployment, which would be even more headache for the security engineering team. So here are some good relevant papers for you to check. So we have AI for SE automation. So this is happening now. So we have a survey for large language models for software engineering. So large language models are deep learning model trained on a large data set such as ChatGPT, but we have many more different LLMs currently. And this systematic literature review actually covers multiple LLM from 2017 to 2023, how these LLM can be built and how they can be applied to software engineering context. I think if you are interested in, I really recommend you to read this paper, because it just lets you know what kind of AI-based application you will see in the future and in the software engineering procedure right now. And we also have the security AI for DevSecOps. So this paper provides a landscape for you. Just review the current AI-based security approach throughout the software planning, from software planning to software monitoring and operation. And we also have some future outlook paper written by some experienced professors, such as the first one is Rethinking Software Engineering in the Foundation Model Era. I would say this kind of paper is quite important. It gives you the thinking, because with the access to many kind of AI-powered tool, the software engineering procedure is slightly changing throughout the development of AI-based models, right? Because with the model's help, we can somehow automate many repetitive job or many security job. It actually make our software development faster, but at the same time, we do need to come up with a new software engineering procedure that works the best with AI models. Currently, we just don't have that answer, and people are still figuring out the answer how we can have a software engineering procedure that works the best for human as well as the AI models. And the other paper is LLM-based multi-agent system for software engineering. So this is how we can leverage multiple AI model to do the software engineering for the future. Like it paves the future vision and future road for researchers as well as the software practitioner to think whether we can have a team of software engineer, human software engineer, and a team of AI software engineer, and how human can work with AI in the context of software engineer in the future. So this is, this is still an open problem right now, and I think we'll figure it out in years to come. Yeah. Yep. So basically, that's all for today's talk, and I do appreciate if you can fill out this anonymous evaluation for me. Yeah. So
maybe you can put the link in the Zoom chat.
Oh yeah, sure. I'll put the link in the chat. Yeah, and at the meantime, if you have any questions, you can speak out or prompt in the chat. I'm more than happy to discuss with you, answer your questions, because there is just too many AI application at the moment for software engineering. I couldn't cover all of them, but I wish that I've covered most of the important ones for you. But if you have any question about deep learning or software engineering, feel free to ask. Just a quick question. What will be the next direction of AI? Next direction of AI, I like how improving itself. Okay. I would say, from my understanding, this question is for the development of deep learning models, like how we can further improve the AI, next direction of AI. I would say currently we have a really large model such as ChatGPT, and I actually don't know how it goes, but I can recap some of the history for you. For example, like in 2017, we first have the transformer architecture, and from the deep learning perspective, why it leads to large language model. The reason is that it can learn from a huge amount of data. So from that on, people are just like competing with each other, trying to train larger model. So we have ChatGPT with 1 trillion parameters that is trained on terabytes, much online data. But up until now and last year, so I think another turning point is ChatGPT, where people figure out a better way to label their data and further increase the performance of the AI model. So we have the production of ChatGPT. So if you check the OpenAI website, ChatGPT was actually trained using some label from human experts. So the training procedure involves the human intervention to some extent, and it further improves the ability of a large language model. So I would say that instead of just feeding much data into the model, right now people are looking how we can leverage these model more intelligently to train leverage this data intelligently to train the model instead of just stacking data and make the model bigger. Because if we have a gigantic model, it also will consume a lot of energy, and it will be the problem, because if you have a too large model, it probably will cost you too much to run the model, and it's just not compatible to the business requirement to use that kind of large model. So better training method rather than bigger model. Yes, but I think so far they are still trying to build bigger model, but the increase of model size is not that crazy like 2 or 3 years ago. But they are figure out better training methods as well as the bigger model at the same time. And I would say most of the top-notch AI research are in Google, in Microsoft, NVIDIA, and OpenAI, and also Apple, Stanford University. So if you check the there are some good resources that you can check for learning how the AI model is built nowadays. You can check OpenAI's website. You can also check NVIDIA's website, where they have different kinds of method of building AI. And another research direction is the AI safety. So right now, before we can use, for example, if we want to use a large language model to build a chatbot for customer service, we may need to consider the ethical issue and the safety issue. So if AI generated something back to your customers, that's not what you want. So people are figuring out what's the approach, how can we safeguard the AI. So that's another direction about the AI security. And it's really a big direction for research as well as in the industry. Thank you.
Okay. Any other questions? If not, maybe I would like to ask everyone to try to complete the form as well, because yeah, he's trying to collect the evidence. We want to seek feedback as well from you. How well is his teaching, and yeah, that kind of thing. Okay, so yeah, thank you so much, everyone, and especially Michael, for giving the talk today. And I hope everyone will enjoy the lecture and enjoy the rest of the week. Yeah. Thank you so much. Yep. Bye bye.
Thanks, guys.